Okay, this is solving systems by elimination. We graphed equations before. Now we're going to see how we can solve them using elimination. I'll remind you what a system is. We got 2x and 3y equaling 9. And then I got another equation here, negative 2x plus 4y equals 12. And this system here is not, if we could graph it, we could see where they crossed each other. We're trying to look for the input that makes the same output. We're trying to solve both of these at the same time. Which input makes the same output in both of these? What we're going to do is we're going to do something we've never done before because it never made sense to do it. What we're going to do is we're going to combine equations. And we never wanted to combine equations before because it would make our life worse. But I want to put something up here and then I want us to think about it. Let's say I had some equation, like simple one, right? Like 2 plus 3 is 5. And right, left-hand side equals the right-hand side. I'm going to make another equation. Let's do super simple, like 1 plus 1 equals 2. So these two equations, what if I wanted to put those two equations together? What if I wanted to add an equation with another equation? Can I do that? And will it still make sense? So what I'm going to do in this example here is if I take everything that's on the left, can I add that to everything else that's on the left? Is that allowed? Over here I got 2 plus 3. Can I add that to the 1 plus 1? Is that the same then over here on the right adding 5 to the 2? Is that allowed? It is. If I write it. So if I just add up all the stuff on the left-hand side, there's a 2 plus a 1 plus a 3 plus it's all this stuff all on the left. I'm going to add that all together, and on the right I'm going to add 5 and 2. We'll see if this still makes sense. If I add all these things on the left, 2 plus 1 plus 3 plus 1 makes 7. On the right, I got 5 plus 2, which is also 7. And yay, look, we're still left with a true statement. And we're going to have to trust me here, but this works for all equations. You're allowed to add one equation with another equation to get a third equation. Usually you don't want to do this because it doesn't help at all. But in the case of systems, it's super handy. Because the whole problem with systems is we have two variables. All right, this is where we have x's, and then we also have y's. And you can't solve an equation that's got two variables. We need just one variable to solve the equation. So we're going to use this trick of adding equations, try to make our lives easier, and solve the system. And looking at this one, does anybody see what's going to happen if we add those two equations? You're writing that here. You can pause this. You don't have to figure it out right now. But if you look at those two things, the x is here. There's a 2x and a negative 2x. If I add those two together, those two x's are going to turn into 0 x's or disappear, cancel each other out, destroy each other. The x's will go away. If I add these together, I lose an entire variable, which then makes the system solvable. So our goal for all of these things is we're always going to try to eliminate one of the variables. If we eliminate one of the variables, then we can solve an equation, just like we've normally done before. Remember, if you need more time, you can pause this, but I'm going to go on. So here's an example. We'll do that example we just were looking at. Call it example 1. So I got 2x plus 3y makes 9. Then I also got negative 2x's plus 4y's equals 12. And what we're going to do here is we're going to add these two equations. Eliminate. In this case, we discussed it. We're going to eliminate that x variable. So this one here is going to disappear. So I'm going to add. Pretty much going to add like terms with like terms. Equal sign is going to stay in the middle. All right, so here we got 2x's minus 2x's makes 0x's. I'll write it, but it's going to go in a second. Here we got 3y's and 4y's makes 7y's. And on the right-hand side, we got 9 plus 12 makes 21. So 0 x's. This is 0, right? 0 times anything is 0, so I'm just going to erase that because we don't even need it. Look at how simple and happy our equation has become. We got 7y equals 3. Nice, happy. You can probably do this in your head, right? We went from a very complex set of two equations. Just by adding them together, the x's disappeared, the y's got together, the regular numbers got together. We left with a simple equation that you've probably done in your head. But just we'll divide by 7, get y equals 3. Yay, almost done. Right, we're halfway done. So recall for these, a solution is going to look like a point, something comma something, right? The x comma the y. We're looking for the x and y that both are the same. We just figured out what the y was. The y was 3. Now, how can we use this to figure out what the x is? Well, we're going to take this and we're going to substitute back into one of our original equations. It does not matter which one we pick up here, but I'm going to substitute it into this first one and rewrite it because we now know what y is. Y is 3. In this equation, we know what this y is. It told us right here. Y is the same thing as 3. So in this equation up top, we don't need a y anymore. We can put a 3. I'm going to rewrite that top equation with the y being 3. So again, at the beginning, we got 2x plus 3 times y. Y is 3. Multiplying by 3. 3 times 3 is 9. And that's going to equal 9. All I did was replace this y with what it said y is 3. 3 times 3 is where this 9 came from. Again, if you get stuck, pause, wait until you see it. But now looking at this is a regular two-step equation. We do our 2 steps and solve it. We're trying to solve for x. Get rid of the 9 on the left. So 2x's is all that's left over, equals 9 minus 9, 0. And then our final step, you haven't seen it yet, divide by 2. We get x equals 0. Here we got x equals 0. That is the x part of our solution. So way over here on the right, our solution, we know x is 0. And this is the solution that solves this system. Recapping, we use that property of adding the two equations together to eliminate a variable. In this case, we got rid of the x's because 2x's minus 2x's made no x's, went away. We were left with this nice, happy, simple equation that many of you could just do in your head. That's where we got y equals 3. Once we knew that y equaled 3, we substituted it back into the equation and just rewrote it as this one. So 2x's plus 3 times 3 was 9, equals 9. And then we solved this one. Two-step, we got our x equals 0, and we filled that in to our solution. We'll do one more for you in the next video, and then also one from the worksheet. But that's pretty much it.